In this lesson, we're going to begin talking about domestic refrigerators and freezers. This lesson goes along with Chapter 11 in the Modern Refrigeration textbook. When you come away from having viewed all the videos in this lesson, you should be able to discuss the construction of domestic refrigerators and freezers. You should be able to describe the refrigeration mechanical components and cabinets for the different types of refrigerators and freezers, and you should be able to compare standard circuit diagrams and ladder diagrams of the systems. You should also be able to discuss differences in circuits for manual defrost, automatic defrost systems, and demonstrate how to repair damaged cabinet finishes. As with any of these, we also want you to be able to follow approved safety procedures as you're servicing this equipment. So let's begin with what the average parts of such a system are. First of all, a domestic refrigerator freezer consists of three parts. You have a cabinet. That cabinet contains and supports the evaporator and condensing unit. You have all the refrigeration mechanical components such as condensing unit and evaporator, and you have the electrical circuit, all of the circuits, relays, and overcurrent protections. Foods last longer when they're kept at a temperature just above freezing. The lower temperatures slow down oxidization, reduce multiplication of bacteria, and reduce evaporation on the food. What we want to do is we want to prevent enzymes which cause food spoilage, and we want to make sure we slow them down by these low temperatures, and we want to keep them destroyed by pasteurization. Colloids are also found in fresh foods. They're cell containers. If broken down, food deteriorates. Low temperatures can slow colloid changes. Fast freezing of food produces small ice crystals and is less damaging to food. Slow freezing allows time for large ice crystal growth and increases colloidal damage. When you store fresh foods in the refrigerator, air in the refrigerator should be dry. Moisture in the refrigerator collects and condenses onto the evaporator surfaces and thus is taken off. Food containers should be covered and airtight. Cabinet temperatures should be kept at around 35 to 41 degrees. The FDA requires 41 degrees for product temperature. At the above temperatures, fresh foods will last 3 days to a week. If you store foods in the freezer, it's frozen food. Air in a food freezer is very dry. Moisture in the air will condense on the evaporator surfaces, and food packages must be tightly sealed. To remove air from packaging prior to freezing, hot foods should be allowed to cool prior to the freezing. Freezer burn is a problem if foods are indicated by changing color or the outside appearance of the food. Frozen foods may be kept for several weeks at 0 to -10 degrees. Foods can be kept for a year or more, should be frozen at -20 degrees or lower. All of this requires proper insulation in refrigerators and freezers. Insulation lines the walls or the refrigerator and freezer cabinets. It prevents heat from leaking through the walls and into the cabinet. Remember, heat moves from areas of high heat to low, so it's not the cold that leaks out, it's the heat that comes in. Urethane foam or fiberglass are the most commonly used insulators in household refrigerators and freezers. Starting off with a simple refrigerator, single door manual defrost. A simple system consists of an evaporator inside the cabinet and condensing unit. Evaporator can be placed across the top of the cabinet or in front of the upper corners. Condensing unit is located under the back of the cabinet. This is an example of a single door manual defrost. The cabinets are made of pressed steel with welded seams. Outer shells must be smooth and vapor-proof. Inner shells provide brackets for mounting shelves, lights, etc. Insulation is installed between the outer and the inner shells. The light switch is located at the hinge side of the door. It turns the light on and off as the door is open and closed. Plastic trim piece, the cold band, is used just at the door opening to reduce heat flow. The mechanical components of a simple refrigerator, they include a hermetic compressor in the cabinet base, a condenser at the bottom or back of the cabinet, and an evaporator inside the cabinet. The way this works, liquid refrigerant enters the evaporator. Refrigerant boils, absorbing heat in the evaporator. Vapor is drawn through the suction line to the compressor. In the compressor, vapor is compressed to a high pressure temperature. Compressed vapor flows through the high pressure vapor lines into the condenser In the condenser, high pressure, high temperature vapor gives up heat to the surrounding air. Vapor is condensed back to liquid. The liquid refrigerant flows through a filter dryer. It enters the capillary tube, and then warm refrigerant gives up some of its heat to the cold suction line vapor, increasing the superheat of the vapor entering the compressor. Low pressure liquid then enters the evaporator, and the cycle is repeated. And this is an example of the refrigeration cycle. You can actually see we have our compressor, out of our compressor to the condenser, out of the condenser to the filter dryer, through the cap tube metering device, into the evaporator, out of the evaporator into the accumulator, back down through the suction line into the compressor, and our system starts all over again. We have to be able to get the ice off the evaporator coils in the freezer because it will not melt on its own. So domestic refrigerators require some of the older models require manual defrost. Turn off the refrigerator overnight. Use a drip pan to catch the condensation from defrosting. Turn the refrigerator on and place a pan of hot water near the evaporator. Never use a metal scraper on the evaporator surfaces. There's a danger of puncturing it. Each time a unit is defrosted, use baking soda and water to clean the evaporator and inner refrigerator surfaces. The electrical surface circuits are relatively easy. Electrical supply is fed through a grounded service cord and a plug. 2 circuits are provided for the panel-mounted disconnect. One circuit is a cabinet light controlled by the cabinet switch. The second circuit is to the motor compressor. There's a thermostat in series with the second circuit that controls the compressor. This is a wiring diagram of such a simple domestic fridge. Cabinet temperature reaches a predetermined point. In other words, it goes up. The thermostat closes, completes the circuit through the motor. The compressor runs and the refrigeration cycle begins. Temperature inside the cabinet reaches a desired point. Thermostat turns off the current and the motor to the compressor stops. There's some additional electrical devices you'll find on some domestic refrigerators. For example, a perimeter dryer. The electrical resistance or heating wire is located in the trim on the freezer door. It operates constantly. It provides a warming effect to halt condensation on the exterior cabinet and around the freezer. Sometimes you also have an ambient compensator. It's an electrical resistance wire. It provides continuous small heat into the refrigerator compartment. It causes the refrigerator to cycle if the ambient room temperature drops below the normal thermostat setting. It's attached to the refrigerator compartment thermostat. It's energized only on the off cycle. On the motor controls, there's a starting relay, connects both the start winding and the run winding to the power circuit. It disconnects the start relay and the starting winding when the compressor motor reaches 75% of its running speed. The starting relay provides overload protection for the entire motor as well. The overload protector contains a resistor in series with the running current. If the current draw is too great, the bimetal contact will break the circuit. This is an example of the motor control. Thermostat comes in, sends power to the starting relay, which actually causes both the start and the run winding to get powered until the start winding drops out at 75% of the running speed. There are more and more systems out there with automatic defrost. When you have a freezer, air in contact with the evaporator surface below freezing temperatures will cause moisture to condense and form ice on the evaporator. The refrigerator and the freezer evaporator must be defrosted to maintain efficiency. Most refrigerators provide a system for automatic defrosting. Hot gas defrost uses solenoid valves. Heat from vapor in the compressor, discharge line, and the condenser are used for evaporator defrosting. Electric heaters may also be used to melt ice on the evaporator surfaces. Frost-free or no frost cycle refrigerators have the evaporator located outside the refrigerated compartment. While running, air is drawn over the evaporator. This air is forced into the freezer and the refrigerator compartments by a motor-driven fan. During the off cycle, the evaporators automatically defrost. Evaporator condensation is carried to the evaporating pan. Heat from the compressor evaporates this moisture into the room's atmosphere. There should never be any visible frost accumulation. The mechanical components of these systems may provide multiple temperatures in the refrigerator with a freezer compartment. The evaporator is refrigerant evaporation, provides heat absorption cooling. The motor-driven fan forces air over the evaporator through ducts, providing all necessary refrigeration temperatures for the compartments. The motor compressor suction line from the evaporator extends down to the inlet side of the hermetic motor compressor in the compressor base. So here you see a multiple compartment. The condenser, it's a wire and tube type, forced air circulation provided by the motor and fan, located at the back of the compartment containing the compressor and condenser. Cap tube metering device allows the refrigerant is condensed in the condenser and flows through the high side filter dryer into the cap tube. This capillary tube is attached to a section of the suction line, providing heat exchange between the two components. Refrigerant flows into the evaporator, completing the cooling cycle. There are several heating devices used as dryers. Electronic resistance heaters controlled by a timer automatically defrost the evaporator. The temperature of the cabinet are regulated by the temperature control. Electricity is fed through the grounded service cord and plug, and the machine compartment connector block provides electrical connections to many components. Hot gas automatic defrost is accomplished through the use of solenoid valves. Heat from the vapor in the discharge line and condenser is used to defrost the evaporator. The defrost timer and solenoid are housed in the cabinet base, and it also may use a perimeter hot tube dryer to provide heat and provide condensation. This is an example of hot gas defrost. Again, you notice the solenoid valve down at the bottom left hand of the slide, and the hot gas will actually bypass the metering device and the condenser when we're in defrost mode. In these two compartments, sometimes two evaporators are used. One is in the freezer compartment and one's in the refrigerator compartment. Refrigerant, both liquid and vapor, leaves the freezer evaporator and flows into the refrigerator evaporator. Vapor is drawn back to the compressor, compressed and discharged into a water evaporating plate and coil assembly. Moisture is evaporated, and then the compressed vapor flows through an oil cooler line in the bottom of the compressor. The vapor then flows to the vertical wire and tube condenser. Heat is given off. Compressed vapor returns to a liquid state and flows through the filter dryer. The liquid flows into the capillary tube that is soldered to a suction line, serving as a heat exchange. Temperature of the liquid refrigerant is reduced, and the superheat of the vapor in the suction line is increased. Refrigerant enters the freezer evaporator at a reduced pressure, evaporates, absorbs heat from the inside of the cabinet, and completes the cycle. If we need defrost, in other words, if there's ice building up, a solenoid valve opens and hot gas defrost cycle begins. Water from the evaporators is drawn into the compressor. It discharges onto the water evaporating plate, heating the surface. Hot compressed vapor flows through the drain sump bypass line and flows into the freezer evaporator. Vapor flows into the refrigerator compartment evaporator through the accumulator. It flows back into the suction line of the compressor. This is an example of a hot gas. The defrost timer is a timer that controls the solenoid device. It's driven by a self-starting electric motor which is geared to turn the shaft slowly. It completes one revolution every 8 hours of compressor operation. When the timer opens, the solenoid valve defrost cycle and continues for 17 minutes. Solenoid valve then closes and the refrigeration cycle resumes. The electrical is supplied by grounded service cord and plug supply electricity, then goes to a panel mounted disconnect from which the various circuits are fed. And if you take a look at this diagram, you'll see that there's a number of other circuits. You have ice makers, you have fans, you have sump pumps, you have perimeter dryers, you have lamps, you have lamp switches. So it's a pretty complex circuit. Another type of refrigerant is the frost-free refrigerator and freezer. It may be fresh food on top, freezer on the bottom. Evaporators in the upper back part of the cabinet, and the condensers along the back section. The fan moves the cold air from the freezer evaporator into the refrigerator compartment. A second fan circulates room air through the cabinet bottom and over the condenser. The doors are held shut by magnets. This is an example of the frost-free refrigerator. Electricity is fed through grounded service cord and plug. 2 electrical resistance heater elements are in the cabinet. The evaporator defrost is electrically heated, and the resistance of the electrical components are all indicated in ohms. This is an example of the electrical circuit. Okay, this is the basics of it. Now in the next lesson we are going to come back and we're going to talk more about the various types of refrigerators that are out there.